Bismillahirrahmanirrahim. Today, inshallah, we will continue our journey in algebra and talk about solving equations. Okay, so the first thing that we must understand is what do we mean by an equation? See, if I told you this 3x plus 5, that's not an equation, that's an algebraic expression. It's just it's like in a phrase, a clause that is incomplete. It's like mubtada without the khabar, so to speak, subject without the predicate, however you like to say. So it's an algebraic expression, it's not an equation. But if I write this, 3x plus 5 equals 7, okay, this is an equation, okay, because it has this equal sign. An equation is an expression of equality. Expression of equality. And that's the key to understanding this concept. In other words, whatever's on this side is equal in value to whatever's on this side. So, you know, the classic example, if you have a a weight measuring device like this, right? And if you put 3x plus 5 over here like this, 3x plus 5, its weight, so to speak, figuratively, will be equal to 7. Okay, and that's a balance. I mean, these are a balance, and they would be perfectly straight like this, right? So that's this measure of equality right there. That's what this means, that these are equal in value. And that's the basic concept of equation, and that's what we use to solve. For example, if you have a measure, a balance like this, right? And let's say you have whatever you have over here, okay? And let's say you have, I don't know, here you have oranges, whatever, and then here you have apples, okay? But if they're equal in weight, it'd be like this. If you add something over here, right, the balance will tip this way, unless you add something of same weight on this side, then the balance will remain the same, right? So in an equation, right, to maintain this equality is important, okay, is important. If you add something to this side, you must add the same thing to this side, right, to maintain that expression of equality, okay? If you subtract something from this side, you must subtract the same thing from this side, okay? So whatever you do to one side, you must also do to the other side to maintain this equality. And that's the basic concept of an equation. Now, when we say solve the equation, okay, when we say solve an equation, what we mean is find the value of the variable x that will make this a true statement. That will make this a true statement. Because you can't just pick any value of x and substitute it here and make that a true statement. Okay? For example, if I have in mind like 3 times x will give you 6. I have a number in my mind. When I multiply it by 3, I get 6. Intuitively, you can probably see that's 2. 3 times 2 is 6. But if somebody said it's 1, 3 times 1 equals 6, is that 3 times 1 equals 6? No, it does not. So this would be a false statement. So 1 makes this a false statement, but 2 makes this a true statement. So when we say solve an equation for a certain variable, what we mean is find the value of the variable that makes this a true statement. Okay? That's what we mean by solving an equation. And there's a basic principle in solving the equation. The two analogies I give is like this, okay? When you're solving an equation, the idea is to get rid of everything that's attached to the x. Okay, the x is on this side, correct? X is on this side. you want to quote get rid of everything that's attached to the x. Like this 5 is attached to the x, and this 3 is attached to the x. Okay, so you want to get rid of them and manipulate the equation until you get x all by itself and everything is sent to the other side, so to speak, over here. Then we know x is equal to this over here. Now, mind you, we are not changing the equation. For example, if I say 2 equals 2, okay, I can add 3 to this side, 3 plus 2, as long as I add 3 to this side. Now, the equation then becomes 5 equals 5, right? Now, it looks different, you say. Well, this one said 2 equals 2, and this one says 5 equals 5. They're not the same. Yes, they're not the same equation per se, but the truth of the statement is still there. It is true, right? This statement is true, and this statement is true. So the idea is to maintain the equality. The idea is to maintain the equality. Okay? So what we do when we solve equations is manipulate the equation, change the equation, so that we do something to this side and we do something to that side, and then we do something to this side, we do something to that side, and then in the end you keep doing that until you isolate the x on one side and everything else on the other side, and x equals this, meaning x equal, let's just say in this case, I don't know what it is, but let's just say we get like 5. Okay, it's wrong, I was telling you, but it's x equals 5. Then we know what the value of x is that will make this a true statement. So the objective of solving an equation is getting the variable all by itself and everything on the other side, so you know what the value of x is that will make this a true statement. Okay, that's the concept behind solving equations. Okay, now there's another thing that you must remember. Solving equations is like opening the present. Okay, inside this present, here's a, let's say you gave somebody a present. Okay, inside this present, inside, it's like, I'm going to write like this. Okay, it's like the x, right, inside of it, and then you have a nice little box, and you have it's wrapped, it's gift wrapped, and then here's a little bow tie. Again, you're giving a nice present to your buddy, so you tied it up like this, so you have a gift. Okay, like that. Now, if you were to open this box, okay, you wouldn't take the paper out first, right? And then you wouldn't. Which order would you do, right? First, you would do the ribbon, right? And then you would do the paper wrap, and then you would open the box. That's the order that you would do it in, right? And then you would get what's inside the box. You wouldn't first take the wrap out and then do the ribbon. It doesn't work that way. So the same concept. When solving equations, you start with what's farthest away from the variable, in this case, from x. So in other words, if you want to solve this equation, you want to get rid of this 5 and this 3, right? This 5 and this 3. The 3 is like intimately associated with the x. It's right there, and the 5 is farther away. So the idea is this would be like the ribbon, and this would be like the paper. You get rid of the 5 first, and then you get rid of the 3 until you get x all by itself. Okay, so that's the idea. This is very important. So you start from farthest away from x, and then you get closer and closer and isolating the x. Another analogy I give is like x is like in the middle of an onion. Onion. Has an onion bustle. So what you want to do is here's the onion. Okay. So what you want to do is you want to peel the onion like from the outside in, So you want to peel the onion until you get to the x, right? Now somebody's there, just chop the onion off. No, it's not chopping equations. But you just start from outside in until you get all the way closest to the x. Okay, that's the concept of solving equation. Okay, so the first thing you have to understand is this is what we're trying to do: isolate the x. The second thing is that you have to start farthest away from the x. And the third thing, so these are concepts, you don't have to like memorize, it just comes natural after a while. The third thing is the way you isolate the x is like 3x plus 5 equals 7. The way you solve this is you want to get rid of this 5, okay? And like take it on the other side. The way you do that is you just, you wish you could just like erase this, right? No, you can't erase that. That's hard. So you can't erase it like that. So you do the opposite operation. Opposite operation. In other words, if 5 is added to this side, you want to subtract 5 from both sides like this. Okay, let me say this again. Let me write this. So 3x plus 5 equals 7, right? So you want to get rid of the 5s. It's added to this side. So you want to subtract 5 from both sides like this. Okay. Now, I did this here because I could plan ahead. See, I left a little room over here, right? So I knew because I was going to do that. But so then I subtract 5 here and subtract 5. Now, as long as you do the same thing to both sides, you're okay, right? You're okay. Now, ordinarily, you don't plan it out like this, so the equation would be written like 3x plus 5 equals 7. There's no room over there, right? So you just write it underneath over there. Subtract 5 from here and 5 from there, and then you get, okay, 3x, right? And then you get 5 minus 5 is 0 equals 2. Okay, so that's the third thing. So you do the opposite operation. Okay, so those are some of the basic concepts of solving an equation. You can't get very far in solving equations unless you know what like terms are. Okay? Now you have to know what like terms. And I said, what are like terms? If I ask you what like terms are, you have to say there are two properties. This you must know. Like terms have same variables, same variable or variables, and two, the same exponent. Okay? For example, if I have 3x, okay, 3x and negative 4x, these are like terms because the same variable 3 and x, and they're both 2 power of 1. These are like terms. And then here's another example. 1/2 x squared, okay, and 5x squared. These are like terms, okay? Same variables to same exponents, okay? So, let me give you some like term examples and not like terms. Okay? So, here's like terms. 3x squared and minus 4x squared. These are like terms. Okay, how about 1/2 x squared and square root of 5x squared? Are these like terms? You bet they are, because the same variable to the same exponent. What's this one? 3x minus 4x squared. These are not like terms. Okay, these are not like terms. The reason is because the same variable, but here the exponent is 1 and the exponent is 2. Here's another example. 3x squared y, there's, right? And then you have x y squared. Now there's 1 here, okay? Invisible 1. Important to understand. Now it has the same variables, x and y, okay? But this expression has x squared, and this expression has y to the first, and this has x to the first and y to the square. They are not like terms. You follow? They are not like terms. Okay. Also, you must understand 3 and negative 4 are also like terms. Well, I don't see any variable in there. Well, you don't see it, but they're, they're like terms. They're there actually, like x to the 0, x to the 0 is 1, but we'll get to that later. But constants like this are like terms. So what's the big deal about like terms? Okay. Well, like terms are important because you can combine like terms. You can combine like terms. What does that mean? You can add and subtract. That means you can add and subtract. You say you can't add apples and oranges. Okay, that means you cannot add unlike terms. So like terms you can add. For example, if I have 3x, okay, plus 4x, okay, it's like saying I have 3 apples and 4 apples. How many apples do I have? I have 7x, 7 apples, like that. Okay, this is not, I don't know, this is not 7x squared or anything like that. This is just 3x plus 4x, 7x. 3 of something plus 4 of something is 7 of something. You can subtract them. 3x minus 4x equals minus 1x, or just minus x. See, you can write this as this with the invisible 1 over there. Okay? So the like terms are very important because you can combine them, combine like terms. Okay? So repeat these words, combine like terms, because they are very helpful in solving equations. Okay? You can combine like terms. Alright, so those are some fundamental concepts in solving equations. Let me summarize to you. What I have suggested to you is equations are expressions of equality. Okay, and when you say solving an equation, what we mean is isolate the x on one side and take everything to the other side. Okay, the second thing I had suggested is that you have to start farthest from the x, farthest from the variable, in isolating the variable. And the analogy I gave you was like a gift box, right? And you have to open the gift box from the outside in, right? Here's a gift box. Okay, and then the third thing I suggested is when you farthest from the variable. I forget what was the third thing I said. Fourth thing I said was like combining like terms. Alright, that bugs me because I don't know what I said before. So I'm just going to rewind myself. The first time I actually put it like this. So now here's like terms, combining like terms. But anyways, you can go back and look at them. I'm sure it'll come to me later. So these are some fundamental concepts that you need to know about solving equations. Next time, inshallah, I will go through some specific examples of solving equations, and we will learn how to do that, inshallah. Until then, as-salatu was-salamu ala rasulillah, alhamdulillah rabbil alamin, assalamu alaikum.